Hello, I'm Dr. Zia Tahir, and this video tutorial is Solution to Problem 4 by 35 from Engineering Mechanics Statics, 9th edition by Meriam. Statement of the problem is the truss is composed of equilateral triangles of side A and is supported and loaded as shown. Determine the forces in members BC and CG. So here is a member BC and then there is a member CG. So, as member forces in two members only required, so the best method to solve this problem is using method of sections. So, here are steps to find member forces using method of section. The first one, plan cut. So, to divide that structure into two sections, choose an imaginary cut that pass through the target members. The target members are BC and CG. So then that imaginary cut is there. So that is the imaginary cut. So on that cut, there must be three or less than three unknown forces, and the unknown forces as BC, CG, and FG. And then find support reaction if needed. And support reactions are required here. And then choose a simpler side of the cut with fewer loads, reactions, and fewer joints. So fewer joints are uh, top and left section. This section that has a fewer joints, but to solve that one, reaction at the support they are required. So first we need to find support reactions. Okay, so A support is a pin support, so it must have two reactions, and then E is a roller sport, and at roller sport there is one reaction, and that reaction is perpendicular to the surface. That perpendicular to the surface. So first we need to find the reaction. So before uh, we can apply analysis on top left cut. So these are the steps to find reactions in trusses. So draw free body diagram of the entire truss, ignore internal member, and replace supports with reactions. So that is a free body diagram, and on that free body diagram I can add reactions. So and then pin support has two reactions and roller support has one reaction, and assume convenient direction of all reactions. So I am going to use that a convenient direction of the reactions. So let's say at support A, so there is one reaction A Y, and there is another reaction A X. And at E, the direction of reaction that is a perpendicular to the surface. So that is a perpendicular to the surface, and I am going to name it as RE, reaction at support E. So these are the convenient directions, and then further apply equilibrium to the whole truss, sigma m equal to 0, sigma fx equal to 0, sigma fy equal to 0, and choose the moment point that has the most unknown. So the moment point I'm going to choose here A because it has two unknowns. But before that, I need to resolve that RE in X and Y plane, because here, so that is X axis assumed and that is Y axis. So RE, which is perpendicular to this surface, so I need to resolve RE into its components. So that's again free body diagram, and on that free body diagram, here is RE. So that RE is perpendicular and the support is 30-degree with horizontal. So uh, then a right triangle will form, and in that right triangle, so that angle will become 60 degrees. So RE actually makes an angle 60-degree with the horizontal. So RE can be resolved into two of the components, as one as EY is equal to RE sine 60, and the other one is EX RE cosine 60. The next one. Next, all triangles are equilateral triangles, and for any of the triangle, so in any of the triangle like EF, and if I try to make a right triangle, so then the vertical distances that will become a sine 30, which is 0.5 a, and the horizontal distances are a cosine 30. So simply between joint A and G, its horizontal distance is a cosine 30 and vertical distance is 0.5 a. So now when I have all the uh, components of inclined forces, so then I can apply here sigma m a equal to 0. Now for sigma m a equal to 0, so that L, so about point A, so then that is a line of action of L. So and then that load L is trying to produce clockwise moment, so which is L times by this distance from line of action of force to point A, and that is equal to 2 horizontal distance between the points. So it is going to be minus, because it is a clockwise moment, L times 2 into A cosine 30. And then the next one here, EY. So the line of action of EY is going to pass somewhere. So that is a line of action, and the perpendicular. So EY is actually acting somewhere there, and that is the perpendicular distance. And EY, that is the line of action of EY, and is trying to produce moment in anti-clockwise direction. So it is plus EY, which is RE sine 60 times by the distance, and that distance is equal to 3 horizontal distance. So 3A cosine 30, and then there is EX. So the line of action of EX is going to pass through there. So that is the line of action of EX, and the perpendicular distance, that is a perpendicular distance. So EX is basically acting there, and that is a perpendicular distance, and it is trying to rotate it in anti-clockwise, clockwise direction. So it is going to be minus RE EX, which is RE cosine 30, RE cosine 60, sorry, times by the distance. So A to B distance is A, and then between two joint vertical distance is A sine 30, which is 0.5 A. So that is 0.5 A is equal to 0. So that is actually 1.5 A, because AB is A plus zero point 0.5 is 1.5. So now it can be rearranged, taking L times 2A cos 30 onto the other side and taking RE as common factor. So what left there when taking RE as common factor? It will be 3A sine 60 cosine 30 minus 1.5A cosine 60. Then taking again A as common factor from here, so it left with 3 sine 60 minus cosine 30 minus 1.5 cosine 60. And then A is going to cancel with A, and by putting the calculator, 2 cos 30 over 3 sin 60 cos 30 minus 1.5 cos 60, the answer will be 2 root 3 over 3 L. So now a positive result confirms the assumed direction. A negative result means actual direction is positive. So RE is positive. So it's mean that the chosen direction here, which is towards the surface, that is correct. So once I have find that RE, so now it is possible to find uh, AX and AY, because I have chosen that top left direct side of the section. So I need reactions there. So for that purpose, I can go over simply sigma fx equal to 0, and for sigma fx equal to 0, uh, AX, I have assumed that towards positive x-axis, so that is positive, and then based on that direction of RE, its horizontal component is EX, so which is towards left, so it is negative RE cosine 60. So now RE is 2 root 3 over 3 L into cosine 60 is equal to 0. So then I can find AX. So 2 root 3 over 3 times cosine 60 is root 3 over 3 or 1 over root 3, and AX comes as positive root 3 over 3L. And then I can further go for sigma Fy equal to 0. And for sigma Fy equal to 0, so I have assumed that Ay in downward direction towards negative x-axis. So it is going to be minus Ay, and then the other is L, which is downward, and then Ey I have assumed upward, so I'm going to take at positive. Ey is equal to Re, which is 2 root 3 over 3 with positive sign, L times by sine 60 is equal to 0. So then I can find that Ay as, to take the Ay onto the other side and then taking L as common factor. So then by substituting that in the calculator, so 2 root 3 over 3 times sine 60 is equal to 1. So here all that will become plus L. So Ay is minus L plus L is equal to 0. So that Ay is equal to 0. So now the answers are Re, reaction at E, that is plus 2 root 3 over 3L, which is the perpendicular to the surface. Ax is root 3 over 3L, and that is towards right, and then Ay is equal to 0. So now once I have computed all the reactions, so then I can simply start solving the section, which is okay, section on top and left of that cut. So now once again, after finding reaction, choose simpler side, so that is the upper side of that, and show all external loads reaction on this side, and represent unknown cut member forces assuming tension. So now I'm going to assume members on the cut all in tension. So that is FG in tension, and then CG also in tension, and then that is BC also in tension. And their reactions on reaction AY. Reaction AY, I have just computed that it is equal to 0, and AX is root 3 over 3. So one known here is AX, so which is root 3 over 3L. So, and then I need to find angles for FG and BC. So FG angle for FG is 30. So that angle is 30, which is making with the horizontal. And similarly, BC is going to make angle 30 with horizontal. And then apply equilibrium to the cut part to find unknown. So the best is says that use m is equal to 0, choose moment point that has most unknown. So next I need to find these unknown by applying conditions of equilibrium. To find sigma m equal to 0, I need to choose a moment point that has the most unknowns and resolve inclined members into components if needed. So now inclined members are FG and BC. So I'm going to resolve them into their components. So that is BCY, and its horizontal component is there, which is BCX. And similarly for FG, its component is FGX, and its vertical component is acting vertically downward, which is FGY. And then I need to find, I need to take the moment about point G now. I have to take the moment about point G, but the distance is there. So that distance is 0.5a, and this distance is also 0.5a, and then this distance is going to be, that is a cosine 30. So now I can apply sigma m equal to sigma m about point G is equal to 0. And I have to find here not all the forces, I have to just find BC and then CG. So I'm not interested in GF. So first when I'm going to take moment about point G, so it's possible for me to find that BC. So now about point G, when I'm going to find moment, so what is going on, that BC is acting vertically downward. So it is actually acting somewhere here, BCY, and it is trying to produce moment in that is in anti-clockwise direction, and that is a BC ax. So BC ax, its line of action is somewhere there, and it is trying to produce moment in the moment sorry, into the perpendicular distance. So it is trying to produce moment in anti-clockwise direction again, and then the line of action of reaction is going to pass somewhere here. So that is the line of action of the reaction, and its perpendicular distance is somewhere there, and it is trying to produce moment in G in clockwise direction. So now there are three moments. I'm going to apply sigma mg using these three moments. So then BCY is BC sine 30 times by A cosine 30, and BCX is BC cosine 30, and I'm take that term with L on the other side, and then I can take BC as common factor. So leaving sine 30 times A cos 30 and cos 30 times 0.5 A, and then further I can take A as common factor and take all the term on the other side. So it will become sine 30 into cosine 30 plus zero point 0.5 into cosine 30. So A is going to cancel with A. So leaving L there, and then when I'm going to substitute root 3 over 3 into zero point 0.5 over sine 30 cosine 30 plus zero point 0.5 into cosine 30 into the calculator. So I will get BC as 1/3 L with positive. So now I have BC. So the next ones I need to find CG. So the next one I need to find CG, and FG is not required. FG is not required in the problem. So to find CG, either I can go for sigma fx equal to 0, then sigma fy equal to 0, or sigma moment about any point equal to 0. So to eliminate Fg, I can take moment about point A, because Fg is going to pass through point A. So when I take moment about point A and Fg is going to pass through point A, so its component that will become irrelevant. Then that is a CG. So the line of action of CG is there. So CG is actually acting there, and then the perpendicular distance is A cos 30. So it is producing a moment in anti-clockwise direction. Then BC is actually passing through the point A, and when it's being passing through point A, so the moment due to BC is again 0, and that is the line of action of BCX, and the distance from line of action to the perpendicular force is A. So BC is going to produce moment in anti-clockwise counterclockwise direction. So then I can go for sigma m about point A is equal to 0. So then for BC x, so it is BCX times by A, that is a counterclock or anti-clockwise moment, minus CG times by A cosine 30 is equal to 0. So now BCX is BC cosine 30. So BC is plus 1 by 3L. So I can just put there a third L cos 30 into A, and then times CG A cos 30. So now A's cos 30, I can take that common and take to the other side, or I can simplify it. So after simplifying, a third L minus CG is equal to 0. So CG is equal to plus a third L. So now both BC and CG are calculated. So going back here about the interpretation, the sign of unknown member forces, a positive value indicate tension and negative value indicate compression. Now both of the BC is positive. So BC is a third L in tension, and then CG is a third L in tension. So both of unknown member forces are in tension, and here is the answer: BC is equal to CG is a third L in tension. So that is a complete solution of this problem. Thank you very much for watching.